Hello everyone. In today's exercise, we will be applying Newton's second law. So we're gonna apply the second law of Newton, which is the net forces equals to ma. The figure shows a wooden box that is being pulled along a horizontal plane. According to the figure, what is the horizontal acceleration, which means ax, of the box to the left? Provided that the coefficient of kinetic friction wood on wood is 0.2, so basically we are also given mu k, round your answer to the nearest hundredth. So basically I have an object of 40 kilograms that is being pulled with a force of 110 Newton at an angle of 35 degrees with the horizontal. However, it is experiencing a friction force backward opposite to the direction of the motion, which of value unknown. So to figure out the acceleration along the x-axis or along the motion, we will be applying the Newton's second law that says that the net forces equals to ma, or in other words, A equals to the net forces along the direction of motion divided by the mass. By reproducing the free body diagram of this object, I can see that I have a backward force of kinetic friction, a forward, and a forward in blue. I will be dividing the force of pull into two different forces into its component. First, the y component, F applied x, and the y F applied y, and to the left F applied x. So I have an upward force applied, F applied y. It's useful to always divide your forces into components along the x and the y, and F applied x. Not to forget that you also have the force of gravity, and certainly the normal force. The force normal. So along the x-axis, I see that I only have the F applied x, and in the other direction, the force of friction. So putting them here, so here I have F applied along the x-axis and minus, because it's on the other side, Fk, which stands for the kinetic friction divided by the mass. So the first step is that I will find the first applied along the x-axis, which is the F applied by cosine theta, which gives me 110 cosine of 35 and 90. Step number 2 is to find the force of kinetic friction, knowing that it is mu k normal. However, this normal force is unknown. On the other side, I will try to find the force normal by applying that also I have zero net forces along the y-axis, so it is equal to may, which is equal to 0. However, on the y-axis, I have upward F normal, also F applied y, and downward the force of gravity. By rearranging the formula, I will have F normal equals to the force of gravity minus the y component of the applied force, which will give me mg minus F applied sine 35 or sine theta. By applying the values, the numerical application, so here I have 40 kilograms by 9.8 minus 110 sine of 35, giving 329 Newton. Now, replacing it by its value, let's continue finding the force of friction, which is equal to 0.2 by this 329, and it will give me only a 64.8 Newton. Now let's continue finding our acceleration. Here we have 90 minus 65 over 40, the mass, which will give me 0.606 meters per second squared. Thank you for watching.